All right. Now that we have established computer reboot. Day 8. The Ocho. I think that will be stuck in the back of my head forever. That dodgeball ESPN 8 thing. All right, so we're good. That's what happens when you. All right, so let's open day 8. We can get rid of opt 2 because we're not going to use that for a second. We have process part 1 and process part 2 now, so our binaries don't actually do anything per se. They just kind of read and then process. So I think our bins are just going to live like that for now. Rust Analyzer is having trouble with day 8 for some reason. We have a cargo toml here. I don't know why it's having trouble. Restart the server. Get rid of the dat heap. So lib has everything. I'm going to get rid of a bunch of stuff. We'll get rid of puzzle input 2. We only need puzzle input for now. Process part 1 is basically going to be apply the puzzle input and then do a thing like it usually is. Puzzle input can stick around for a second. Make this like a U size for no reason, just to keep it around. This opt 2 we don't need anymore. This we don't need anymore. Or at least we don't need for the second. We'll get rid of one of these tests. I think, what's the ignore for this? This is it just ignore? I think it's just ignore. Give me a Chrome window, please. Rust ignore test. I don't ignore tests very often. Hello, Commander. How are you? It is just ignore. So we're just going to ignore part 2 for a second. Not worry about it. I guess I could comment the whole thing out since it doesn't even need to be there. So yeah, we're left with basically the puzzle input parser, which is what we usually use to parse the input via nom. Part 1, part 2, and some test setup. I'm stuck in the solution of day 8, part 2. Well, hopefully we will get to part 2 fairly quickly. If not, then that sucks. Let's do this. Let's move this to the other window, even though it's having its own little troubles here. Advent. Hey, Jacob, how's it going? I got a little bit of an advantage today. I watched somebody else. I watched Nikki's stream earlier. So I have seen the problem today, which is nice because it's a little confusing. I try to learn Rust that way. By doing Advent of Code? Yeah. I mean, I really like that as a solution. It's one of the things that I did when I was learning. But the drawback of doing that is that the Advent of Code problems, like, aren't simple problems, right? They weren't made to learn a language. They were made to solve a puzzle. So you have a little bit of friction there. But as long as you're okay with dealing with that friction, I think that advent of code problems are a great way to learn a new language like Rust or something. So let's talk about the problem a little bit. We have basically these 7 segment displays, which are like, the Wikipedia page has an explanation, but it's like this thing on the right here, this image. In my head, they're like the little things that flip like at a train station, but not quite. They're like the old style alarm clocks that people probably don't even use these style alarm clocks anymore, do they? I guess we all have phones now. Dang, this isn't a thing anymore. But the idea is basically like there's a top, a side, a middle, a side, a bottom, a side, and another side. And you can represent basically like a number via an array of bits. So using like 1U8, we could define what this display is. In the problem case, microwaves still use these. You're right. I wonder when microwaves are going to go like touchscreen. Feels like one of the last holdouts, because if you go touchscreen on a microwave, your finger is probably like dirty or messy or something. So like, yeah, I don't know. Tactical buttons feel a little bit better there. But yeah, so basically, this is giving us a list of 9 numbers, right? And if you look at this thing, there's a couple of segments to highlight. So when only the outer pieces are highlighted, it's a 0. Whenever only the right side pieces are highlighted, it's a 1, and so on. So each of the little spots is represented by a letter, a single letter. So this is A, that's C, whatever. The wording in there is super confusing, but effectively we get this, which is like a set of input numbers and a set of output numbers. So our goal for our part 1 at least, is to completely ignore the inputs and just count the unique numbers in the output. So let's pull this in and hope it's formatted correctly. I'm going to do include stir just input. And then here, actually, I don't need to know where I need to put this now because it's in lib, right? Test input.text, and we'll just paste that in there. The test input is not formatted correctly. You are correct. That is really unfortunate. One of those things, you know? So let's fix this test input, I suppose. It's 1 space, right? So 10 lines, a bunch of input, and then this pipe character, and then a bunch of output. And then we include the string using test input.text, include stir macro. The include stir macro is really nice. It allows us to just like compile a string into the binary. So when we run tests, this string gets compiled in. Wonderful. It has new lines for readability, which was a choice. I agree with that. That does not feel like the right choice. Especially given how the website is formatted. Have you noticed, like, the website, if I try to make this big enough for people to read, it just overflows the side. Okay, so what's our answer for the test input? 26. So we need 26. So we have a bunch of lines, and each line will ignore the front half up to the pipe and then only take the bottom or the end for the first problem. So let input outputs equals separated list, because that's easy. New line output. Then we put input here and handle the error. And we'll have function output. This actually doesn't need to be a public function anymore, does it? Output takes input as a string slice. We get an I result, string slice. We don't need usize. This is just going to be string slices, but it's going to be a vec. Right. So then we'll do let outputs. Actually, this isn't going to be outputs, is it? Let input ignore equals there's like an ends with kind of stuff with nom. So let's go look at the nom docs. The whole thing is fixed with, but I don't know what the creator does a lot of web dev. Yeah. I feel like at this point it's been 7 years. It's a design choice and not a bug for them. Respecting to the width of the site. Zero copy, etc., etc. I'm looking for like take until, basically. So this will take up until a pipe or something like that. This does take until end of file. So let's do something like take until tag space pipe space. And then we need to do the same thing because it doesn't actually consume the tag. So we need to do the space pipe space again. And then we let input outputs equals separated list space, I think, at that point. So we end up with a vec of stirs. And this is outputs, because this is going to be a vec of string slices. This is no longer crabs. Mr. Krabs. What is this? This is going to be lines. We'll call it lines. So if we have lines and it's all the outputs, then we need to get all of the unique ones, right? Which I guess is only 1, 4, 7, and whatever. 8. 1, 4, 7, 8. So my question here is, does 5 count if there's only 1 5 in the output? But I don't see any 5s here. So this output has a 5 character. So we're only counting the 1s, the 4s, the 7s, and the 8s. Which I believe 1, 2, 3, 4, 5, 6, 7, 3, 2, and 4. 7, 3, 2, and 4. 7, 3, 2, 4, because I'm gonna forget that. So lines.flatmap the is Rust Analyzer still not working? How are you failing to read the cargo metadata? That's my big question. What is going on there? Oh, you know what? Let's just do a build. Named profiles is required. It's failing to parse the cargo metadata because we aren't using the nightly version of Rust. That are the numbers with a unique number of segment highlights. Yes, those are the ones that we need to count in the output, I believe, for part 1. Let me comment out the DAP profile for a second. Okay, that works. I did something wrong somewhere. I bet you it is not passing in the input somewhere. Yep. There is a so Nom Supreme, the library, allows you to do like postfix. So like all of this stuff that we're doing here every day, which is like a little bit of boilerplate with let input whatever equals take until. Nom Supreme lets you write something like input.take until thing dot like tag dot separated list, like, and then you can just handle it like that, which is kind of nice. I just didn't want to use a third-party library for daily use at this point. Why are none of these imported? Separated list is imported, right? Where's our build? Okay. Trait bound input function input length is not satisfied for what tag? I feel like I used take until in the wrong way. Separated list takes 2 args. Yes, it does. You're absolutely correct. Digit 1. Something is still wrong with both of these. Let's see. Rust compiler, please tell us what I did wrong. Input length is not implemented. Maybe take until is not what I wanted. I thought take until, oh no, take until takes a tag. Oh, okay. That's my bad. I thought it took a parser. It doesn't take a parser. It takes the actual tag. And this does take the actual parser. Okay, so we're back on our stuff. Our bullshit, you might say. Let's just do map. Well, we need to do flat map. I want to do flat map because I want to, like, we have a nested level of X. And what I want at the end of this, when we do like a filter here, is we get a number, right? And the number is it the sum of the, is it the count? I think it's the count. So then we can do uniques. Uniques is going to be our thing up here. 7324. Is it not includes? Is it contains? I always forget. So let me do that. And then we freak out because we're returning the wrong type. Because count is a use size. And then we cargo build, and we cargo test. Unwrap on error value. I messed something up. Probably in the parsing. Oh, digit. These aren't digits. Why did I do digit? Alpha 1. That's what we'll go with. I feel like Nom should have a parsing prelude that makes that a little easier. So we have a passing test now. Let's go get the actual input. Hopefully this doesn't have the new lines. It doesn't have the new lines. Input.text. Paste this in. Cargo run bin part 1. 310. Hopefully this is correct. Yeah, it's correct. All right. Things I learned with this one: don't use space 0 with a separated list. Were you using separated list 0 or separated list 1? Or were you using space 0 as the separator? There are definitely combinators in Nom where, like, if you do, I think many 1 is one of them. Yeah, note, if the parser pass to many 1 accepts empty inputs like alpha 0 or digit 0, many 1 will return an error to prevent from going into an infinite loop. So basically this is like the parser that you pass to many 1 at some point has to fail, right? Because if it doesn't fail, then you never know when to stop, right? So if the separator for separated list can be nothing, then it can just eat whatever, and it will always, like, the separator will always pass, right? So I wonder if separated list has a note about that. Fails if the element parser does not place at least one element, but let's look at the 0 version. It doesn't have a note about that. So you probably could technically use this. Were you getting an actual error, or? Or was it just kind of like running? Okay, so we have the problem here where our test line here, I think this is the test line we want to use. For part 2, we will let line equals this. Of course, it has that weird new line in it. Why wouldn't it? And then the value for this is going to be 5353. Because this is 5353. It was throwing because it was trying to parse empty string with alpha 1. Oh, so it was failing on the input, not on the construction of the parser. That makes sense. Maybe we don't want to do this. Okay, so to go over part 1 before we do part 2, what we ended up with part 1 for was we got all the outputs. We had a vec of vecs. Flat map, if you're not aware, will take an iterator. So we haven't noted notice that we have an iterator here and we aren't collecting, right? Because flat map will take the interior vecs, which we iterate over, and we map to the length. When we return the vec from this, it will flatten that into the root vec. So then when we filter here, we get to operate on each of the length numbers as if it was a single vec rather than being a nested vecs. Might want multiple tests for this one because deductive logic. I might want multiple tests for this one. We do need a puzzle input part 2. Let's put this down here. So what we'll end up getting here, or what we want here, is probably the inputs and the outputs. So this turns into a vec of inputs, outputs, which are themselves vecs of stirs. I actually don't know that we want stirs here. I was reading the problem and I was thinking maybe hash set would work well. Because one of the things that we're going to need to do is compare them to each other. So hash set in Java. No, we write Rust on this stream today. So hash set should be something that we can just insert stuff into and it keeps the uniqueness. And then the big thing here is I think we have intersection. And we have, what is it, disjoint? What's the one that isn't difference? The values that are in self but not in other. So I want to use hash sets here because we're going to be able to do like difference and intersection rather than doing other stuff. So this will be not actually a vec of strings. It'll be a hash set. And then I think these still get to be string slices because it'll be a hash set of cars. My part 1 uses a bunch of those, ended up not needing them, I guess. Yeah. It did look like you were doing a bunch of part 2 work in your part 1 solution on stream earlier. What are we doing here? We're doing puzzle input 2 hash sets. Let's get new parser here. And we can turn this into a, do we need a vec here? We need a tuple of hash set, car, and the other thing, right? And then this needs to be transformed into this. Which I believe just works. So if we grab this and we drop it in here, and we call this inputs, and we return the inputs and the outputs. This isn't output anymore. This is now, I guess, like line, or what do we call these in the problem? Signal. I'm just gonna call them signals, I guess. Separated list, alpha 1. Inputs.map. Then we have a string dot.cars collect into a vec, or into a vec, no, into a hash set. Iter. And then we run into a problem because expected vec found tuple. What did I do? Iter map. Inputs is this is each line, right? So inputs dot iter should give me an iterator over all of them. Hash set car. Oh, yeah. Inputs.iter.map s. S is a string, right? A string slice, which we then iterate over with cars. Cars collects into a hash set car. I feel like that should work. I guess found tuple. Let's do sets, and let's do sets equals this, so that we can get a little bit of a different read on what's going on here. I didn't collect the whole thing, which is the problem, I think. Collect. And I think because we have sets here, so because we're returning sets here and we're defining sets here, Rust can infer that collect means that we need to build it into the thing that returns from this function. So we have the hash set of cars. I'm going to call this stuff for a second. Why is this a vec of strings? Separated list, new line. That says output because output is now a thing that's in this file. We need signals. Outputs should be the thing now, right? Cool. This will be lines. Honestly, Rust type inference for stuff like that is really, really good. Yes. I feel like people are surprised when they come to Rust from stuff like TypeScript, because TypeScript's inference for this kind of stuff is not as good as like a language that is built for that from the start. And I mean, TypeScript has other constraints, so it's nothing against the language or anything. I just enjoy working with Rust more because it does these kinds of things for me and is built for this from the start. Got Jamba Juice this morning. Okay, so we've got the lines, we've got the hash sets. Let's see. Lines dot. We're probably mapping over this, right? Because we need to do something for each line. What do we want to do here? We want to iterate over each line. For each line, we want to determine what the numbers are and what the outputs are based on those numbers. And then we need to return which number? We need to add all of these together. So we need to return all the readouts. So we're going to end up doing a sum here. This is going to be line. I want to say that C# inference isn't as good as Rust either, despite not having the same constraints as TypeScript. I don't know anything about C# really, so I can't really speak to that. I will say that the kind of inference I'm used to is the kind of inference that you get from something like Haskell, which is really advanced inference. So when I run into stuff that's like less capable than that, I kind of like don't enjoy using it as much, because I don't expect to have to do all of these things to like define all my types in all of these different places and keep retyping the same types and stuff. And I find that Rust holds up to that bar better than some other type languages that I've used. Okay, so map, iter, line. We can put a function in here, a function pointer, rather than a closure. So maybe we do that. What's the type here? It's going to be a tuple. Sets outputs, which is going to be a tuple of a vec of hash set car. Speaking of type inference, it is mandatory in Rust that you type your function signatures. And this, in my opinion, is a really good choice, because you can get into a lot of really interesting type problems if you don't do that. For understanding, a hash set is a hash map key value where the value is unique. A hash set is just like a set in any other language. So if we go up to the description here, the backing value is a hash map, but the value is unit. So we only care about the keys, basically. In practice, this turns out to be like a set in JavaScript or a set in any other language. What did I do? Is this... Yes, type mismatch. I know that. This is going to be a reference. Why is some complaining? Oh, each line, iter, map, process line returns a usize. Why can't this infer? Oh, one thing that I do have to do actually, now while I'm thinking about it, is let sum equals this, and then we have to return sum here. And then we can match everything, and now it can infer. Basically, because we've defined it on the function level, we don't need to define it inside of the function. Okay, so we have the sets and we have the outputs. I think Nikki sent me something earlier that's going to be super useful here. So when we get, what is it? 7, these numbers are not the ones that we really care about. Right? Because this is actually numbers, what, 1, 4, 7, something like that. 1, 4, 7, and 8. 1, 4, 7, and 8 are all unique. You forgot the number 0 in that photo. It's all good. So maybe we get a hash map. Where it's like, I'm just going to usize everything for now. Usize and usize, even though these could be very much like oh, I guess we can do hash map from too, right? So if we do from and we do an array of tuples, I think that'll work. So let's pull in hash map. I'm basically creating a lookup. Tuple structs and tuple variants. Okay, fine. For some reason, I thought hash map from was constant, but I guess it's not. Why do I think that? I think it's because I'm used to using lazy static for these. We could use one cell. That's fun. Have y'all seen one cell? I vote for one cell on the basis of I don't know what that is. Okay, we can do one cell. I like one cell a lot. So this is going to be map. I don't know what we're going to call that. This will be U size, U size. I don't think we need a mutex here. I think the mutex is just like an example. Because they assume that you're going to like insert it or whatever. So we'll get rid of this mutex. One cell only ever gives us back references anyway, so we don't ever really need a mutex here because we're never going to mutate this hash map. Stuck U size found. Oh, right, because I did their initialization and not mine. Okay, so we're not using it right now, but let me explain what we're doing here. So your goal here is to create a type of answer key, right? Yes, more or less. My goal here is to create a list of the numbers themselves and the number of segments that they need to be like valid or whatever. So like 0 is actually not 0. That was just a test. 0 is 1, 2, 3, 4, 5, 6, right? So 0 has 6 segments. And then 1 has 2. 1 is unique though, so I think that maybe this doesn't need to be done for that, but we'll keep going. 3, 4, 5, 3, 4, 5. I don't know that I need to encode this way, but I'm going to for the moment, and then we'll figure out. 4, 4, 3, 4, 5, 5, 5, 6, 6, 4, 4, 5, 5. Is it really 6, 6? Is that what I just said? 1, 2, 3, 4, 5. Yeah. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 6. So 3, 7, 6. Right, and now we kind of have a list of the I guess this should really be flipped. Now that I think about it, we need to access which number it could possibly be based on how many characters are in the thing. Let's do this first. Let so the first thing I want to do here is we have this list of stuff, right? And I want to filter out and capture all of the ones that are unique, I guess, or like the ones that we know. So maybe I do need to create this in here. Because the thing that we're going to do to figure out which one is which is going to end up being something like, let's find a good example. Let's see, we have 4 here, right? 4 has 4 in it. Let's see, 7, 6. Is there any with 6? So there's 9, 6, and 0 with 6. And none of those are going to be the last ones. So let's do one of the other ones first. Let's see, what numbers do we actually have? 1, 4, 7, and 8. So 7 here. It's not super useful. 1, 4. This is 2. That's 3. And then we have 1, 4. So 5 is probably the next one. So 5 can be 2, 3, or 5. And then 0, 6, or 9. That's the right amount of numbers. So we have 2 batches here. We have 0, 6, and 9, and we have 2, 3, and 5. So the question is, if we have 1, 4, 7, and 8, which ones can we identify out of that group? So let's start with 2, 3, 5, right? 2, 3, and 5. 2 is unique because of the bottom left vertical slice. The thing I kind of want to do here actually is build up a representation of which wall is which one, I think. There are 2 things going in my head. It's like, can we do intersections here to figure out what the leftover is? And then we need to match that up against an actual wall. So like, if we have 1 and 7, then we know A is top, right? By doing an intersection, or not an intersection, a difference. So let's do diff 1 and 7 yields top bar. And then what is it? 1, what are the other 2 that we have? I keep forgetting the numbers. I need these on the same wavelength over here. 1, 4, 7, 8. So we have a full, which is useful, right? Because then we can do maybe a couple intersections to peel something off. What shapes can we make out of this? If we know what the top one is, you can identify the unique ones. 1 length 2, 7 length 3, 4 length 4, 8 length 8, then all 1, 7, 4, 8 have segment F up 2 on. If you know F, then C is the second one in the 1. No, I don't think C is the second one in the 1. right? We do have F in all of them. Oh, you're saying check to see which ones all have a same character. So union all gives us C. Intersection of all of 1, 2, 1, 4, 7, 8. Yields top right vertical. So F, 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 F. Well, actually, the intersection gives us the bottom right vertical, right? And then we can determine the top right vertical from that. I was really worried that they weren't giving us every possible digit in the sequence. No, I think so my assumption right now is that we get every number. 2, 3, 4, 5, 6, 7, 8, 9, 10. I think that for every single one of them, we get every number. All of these are horizontally aligned here on the right-hand side. So without even going through this and checking, I know that every character on this entire line is the same, like it occurs the same number of times. And I don't think that we get duplicates or anything like that. Which would have made this maybe a little bit more difficult. Not actually. We would have just pulled it down. So intersection of that, and then intersect of previous and 1 top right vertical. So now we've got the top bar, the bottom right bar, and the top right bar. And it's just a matter of digging through this. Yeah, they didn't do a good job explaining. Oh, I imagine, you know, I feel like a lot of people are like, oh, my reading comprehension isn't good. But I feel like when so many people have reading comprehension issues on the problems, it's not the reader's problem at that point. Okay. So we have top, what's previous in that sentence, the line before it. So if we intersect 1, 4, 7, and 8, we end up with the bottom right vertical letter, right? And we'll have a hash set of the bottom right vertical letter. So if we intersect that with the number 1, if we have F and we intersect it with 1, or difference it with 1, sorry, it's not intersect. I'm going to do that at least 3 more times today. If we difference, I guess if we difference them, yes. So if we have a hash set with F and we have 1, then we get C. So we get top right. One, 4, 7, 8. Yes, you do get both of them. So this isn't true. Sorry, it's tough to read chat, debug chat, and also work on the problem at the same time. So I might miss stuff like that. I appreciate you pointing it out. Okay, so what are we looking at? So we have A, right? And we can eat stuff out of 8 and use 8 against other things. But we don't have much more information total. You can just put it in chat, Nikki. It's all good. At this point, we're basically just working through what all of the steps are going to be, because I'm pretty sure they're pretty deterministic in terms of how they're going to work, because all of them are in the same positions. All we need to do is figure out which intersections and differences to run through, and then we'll get the letter. So if you have one, just paste it in chat. What are the other ones? So we can't identify any numbers with just A, right? Or with A and CF. If some hash set has length 5 and is a superset of a hash set for 7. So 1, 2, 3, 4, 5. I don't think we have that yet, though. But we do have... We don't have a 9 because we have the little tail on the end. I feel like we could get 2. Seven is one of the initial guaranteed yet. Yeah, but we don't have... If some hash set has length 5 and is a superset of the hash set for 7. So it's one of these. Is this 2, 3, or 5? Two, 3, and 5, or 5, right? Yeah, 2, 3, and 5. 3 and 5. If it's a superset of 7, then it's 3. Yes. If hash dot len equals 5 includes all then we have 3. Then we've identified 3, I guess. So with the addition of 3, if we know A and we can get the top and bottom left-hand sides. We can also identify all of the horizontals, but not uniquely horizontals. Ooh, we can identify all of the horizontals using an intersection or a difference of 3 and 1. So diff 3 and 1 gives us then remove top bar and we get the mid and the bottom horizontals, right? And then if we take that and we test which one is in 4, is it intersect with 4? It is intersect with 4. I'm going to include this, which is going to be like this weird pipe thing. That's kind of like a continue from here. Then, what do we need to do? Then diff with bottom. Okay. So if we identify 3 and we we difference it with 1, then we get A, D, and G. If we immediately intersect with 4, we get midline. And if we take that and the fact that we already identified A, and we find the one that isn't A or D, then we have bottom line. In the number 6, the segment C is off. Yes. Yeah, you're good, Nikki. Feel free to think in chat. That's all good. So at this point, if we do this all, we have top bar, mid bar, bottom bar. And we've identified the top and bottom right verticals. But in 5-2. So we have top, mid, and bottom, and we've identified the right vertical. What about but in 5-2? In 6, C is off, and in 5, C is off. Yes, both correct. If we know which one 3 is, then what do we have in the other 5s? 2 and 5? So anyway, we have top bar, mid bar, bottom bar at this point. And we can identify the right side bars, which means we can already identify the left side bars just by doing whatever's left over after all of those letters are pulled out. Our goal in the end is to identify all of the bars, not to identify all of the numbers. So can we do anything with 2 and 5 right now that's useful? Ooh, if we intersect, if we look for the 1 and 4 that is not in 1 or 3, then we have the top left side. Can we identify the we don't need to identify the numbers, do we? If we can figure out the bars, then we can go direct to numbers. Can we identify the numbers without identifying the bars? We can do that to an extent. The output is the numbers. I'm aware the output is the numbers. But if we have the bars, we know the orientation of all of the bars for all of the numbers. We can focus on numbers, though, and see if that works. So theoretically, we have 1, 4, 7, 8, and 3 now. Can we identify any other numbers from just that? Like, you just mentioned the goal is to identify the bars. Made me wonder if we could do it the other way. Yeah, I'm happy to try the other way. It's possible that we could. I don't know the answer to that question. 2 and 5, I don't know that they're differentiable. Oh, you know what? They are. If we take 3... If we take 4, right? And we intersect it with 2. Don't let me derail you. It's all good. This is kind of a team sport with stream. What are you saying about 9, Nikki? Oh, 3 and 9 would give us 1 left and is a full overlap. So if we have a superset of 3 that is length 6, then we have 9. Right? If we have a hash set 1, 2, 3, 4, 5, 6, the only other 6s are 0 and 6. So 0 is all the outers. Nope. And then 6 is here. 6 minus 3 gives bottom left. But we can identify 9 here, right? If we have either 0, 6, or 9, right? And we, did I say diff or intersect? If we diff 3 with 9, we get B, right? Top left. But if we diff 3 with 6, we get B and E. And if we diff 3 with 0, actually we get BEC. And if we diff 3 with 0, we get BE. So if we diff 3 with a 6 length and there's 1 left, then we get top left. And the top left character. So now we have top bar, middle bar, bottom bar, top left character. And we have four more numbers to go, basically. So what do we have to identify still? We have to identify... I'm going to keep progress down here. We have 1, 4, 7, 8. And then we got 3, and then we got 9. 1, 3, 4, 7, 8, 9. 1, 3, 4, 7, 8, 9. So we need 0, 2, 5, 6. Hash set for 8, take away the midbar, you get the hash set for 0. You're right. So we can go direct from set of 8. What is it? Diff, did we say? Intersect with set midbar. Intersect? Diff. Diff, hash set midbar. Gives us the hash set of 0. So we now also have 0. Which leaves, what? We just killed one of the categories, right? Which leaves us with 6. And then we have to identify 2 and 5. Which I think we can do with 6. Right? No, we can't do it with 6. Are there any intersects union combos for the numbers that we know that can give us either top right or bottom right? 6 union 5 equals 1 left over. 6 union 2 equals 0 left over. Six union 2 does not give us 0 left over. Only 2 and 5, yeah. We have acquired every other number. We haven't written the code for it yet, but we've gotten the number. Wow, for some reason my laptop gets chat faster than my computer gets chat. That's weird. 62 equals length 8. Oh, right. I don't know if we have union. Do we have union? We do have union. You know what? I was thinking that you meant intersection or difference, not union. So if we have 6, U, so that should give us everything then, right? 6 and 2 gives us 8. And 6 and 5 gives us 1, 2, 3, 4, 5, 6. So 7 and 6. The number 8. Yeah. The numbers and the letters and the numbers and the letters are annoying. 6U2 is length 7, 6U5 is length 6. And that gives us everything, right? So now just to code it. So first thing is to identify these ones by their length, right? So let, what are the numbers? 1 equals, to be honest, this seemed like the hard part. Yes. I think it is the hard part, but let 1 equals, I don't think we need known. 1 equals find v dot length equals, what was the length of 2? And this has to work. So we unwrap. It sets, we're gonna iter 5 bajillion times, it'll be fun. And then 4, 7 and 8. And these are 4, 3, and 3, 6, 7. 4, 3, and 7. Okay. Actually, is there an easy way to... I don't quite want to removes and returns the element at position index within the vector, shifting all elements after it to the left. I think this is what we want. So this is going to be mute sets. Actually, we're going to construct the other sets. I don't think we need to do that. Sets.iter .find .filter v dot length equals 5, right? These are references. Don't know that I really care. So we get the length 5s and the length 6s. That's what we were talking about, right? Okay, so we have 1, 4, 7, 8. The length of 5s and the length of 6s. So if we are in length 5s and the hash set includes everything from 7, then we get 3. So 7 is length 3, right? Let's go look at this again. So we have 7. And if it's length 5, which is 3, 2, or 5, and it includes everything in 7. So if we union and it's the same as 7, right? No, not union. If we intersect and it's the same as 7. So let 3 equals sets. No, not sets. Length 5s dot iter dot find v dot intersect 7 equals 7. And intersect is going to happen to operate on, or intersection. Oh, hash sets can't be equaled? Is this going to work? Equality isn't on a hash set, huh? Yes, it is. It's right there. Assert equals on a union. No, it's something else. I think the issue is that this, like, they need to be references or something. Hash set car. Oh, this is an intersection. What does intersection give us? Do we need to collect back? We do need to collect. Value of type hash set car cannot be built from iterator reference to car. So we're just going to solve this by cloning. And we can go back and deal with references and whatever later. So that's 3. If we diff 1 and 3, and then we remove the top bar, then we intersect with 4 for the mid bar. We don't do the bars though. we just continued with just the numbers. Nice speedy debugging. That's definitely a useful skill. Finding why I'm getting this error by looking at the correct part of the docs. When I'm confused about something or why something is happening, I make sure first that I did everything correctly. And then I go into a debugging phase where I'm like, okay, what could be going wrong, right? Because usually, more often than not, the problems that I run into as a programmer are I typed the wrong thing and not there's a bug inside of something. Okay, so we have 3. Next number is 9 to get. So if the hash set length is 6, we do need to remove 3 from the thing, actually. Right? We need to remember to filter 3 out later. We'll put it that way. If the length is 6 and the diff on 3 I didn't write that down well at all, did I? Length of 6 is what? 2 and 5? No, it's 9s. 0, 6, and 9. So if the length of the diff is 1, yeah, we did switch to numbers partway through. It's all good though. If we diff with 9, we get B. If we diff with 6, we get, well, like, let's make sure that we're doing diff correctly here, though. Values that are in self, but not in other. I think symmetric difference is what I wanted here. 3 union 9 equals 9. 3 union 6 does not equal 6. Short interlude. Looking at the amount of people that completed part 2 is interesting. Is it low or high, Nikki? 3 union 9 equals 9. You mean length 9? We also have to apply 0 in that. Don't forget, Derek. If we symmetric difference 3 with 9, we get a length of 1. If we symmetric difference 3 with 6, we get a length of 3. If we symmetric difference 3 with 0, we get a length of something else. Matthew Q, what's a symmetric difference? So difference is the numbers that I have that you don't have. And symmetric difference is the numbers that we have that the other doesn't. So if we look at the difference for, let's say, 3 and 0, right? What we end up with is just C. Because it's the values that 3 has that 0 doesn't have. So we ignore B and E. But the symmetric difference is the values that both of them have that the other doesn't. So we end up with CBE. And I don't know that because of math. I know that because I was looking at the docs. Right. Symmetric difference happens to be right next to difference. I happened to scroll by it earlier. I knew that there was another function. When I came to this point and I was thinking of difference, I realized that what I was thinking of when I looked at this difference is not actually the difference that I was thinking of in my head. So I went looking for the other function that would have satisfied, which happens to be there. Okay, so we have all those 9. We didn't identify any of the bars, so we might have to change how we get 8 or how we get 0 here. So what are we left with? We're left with 0 and 6 in the same one. Which numbers wise, they both work out. But if we symmetric diff 9 and 6, we get 2. If we symmetric diff 9 and 0, we also get 2. Ooh, if we symmetric diff 1 and 0, we get 4. If we do 1 and 6, we get 3, 4, 5, 6. So that's that. So let 0 equals sets dot iter dot filter v equals 3, right? Because no, not 3. 3 equals 9. And then we find v dot symmetric difference with 1 dot length equals, what did I say it was? 4? The flip to look at sets and differences really makes this more approachable than trying to deduce which line is which, so I thank you for that. Yeah, I mean, I'm happy to do things like that, right? This one is going to be that. And then the other one is going to be super easy. So let 6 equals sets.iter, filter 9 out, 4v equals 0. And then we don't difference, we just find. Does 0 need to be I did that the wrong way. Okay, so we are panicking on 128. We're panicking when we're trying to find 9. So I'm going to debug here V. Like, I don't think it matters to me or for your solution if you wanted to do it the other way. That's an option made the solution more conceivable for me when I go to work on it. Yes. But I'm totally cool taking detours to do that kind of thing rather than doing it the way that whatever I would have. So length 6s is which ones? Zero, 6, and 9. Or it should be. So let's do this. And now we're looking at V and 3 is G and B. This is supposed to be D, E, C, G, F. That's 5. Did I use the wrong one? Did I put these in the wrong ones? I did. Whoops. Okay, we're back to panicking at assertion failed. So this was all correct. The issue was definitely that I set it up wrong and not that the logic was wrong. 0, 6. So we have 6 now, right? And if we have 6, that'll do a good catch. Yeah. Like I said, just like the vast majority of mistakes are like programmer error, right? Rather than algorithmically being incorrect or whatever. Please do a quick state so far for your part 2 code, like which numbers are done and which are still unknown. Yes, happy to. So we have 1, 4, 7, and 8, which we are given, right? And this is a bit of a verbose way to find them. We didn't need to do it this way. I did it this way for clarity. And then we constructed the rest of them into 2 sets. One, which is the lengths that have... One, which is the hash sets that have 5 characters. And one, which is the hash sets that have 6 characters. So we get 3 by going through the hash sets with length 5 and doing some logic, right? And then we get 9 from 6s, 0 from 6s, and 6 from 6s. So now what we're left with is just 0 and 3 and 9, right? I skipped them. Did I skip something? Yes. I skipped something. So hash set dot length equals 6, and diff3's hash set is 9. Wait a second. We have 9. 0, 1, 1, 4, 7, 8. 3, 9, 0, 6. 1, 4, 7, 8, 0, 9. 3, 9, 0, 6. We still have 2. What did we do here? 1, 2, 3, 4, 5, 6, 7, 8. And then 6 union 2 is length 7 and 6 union 5 is length. So we need to do 2 and 5. Almost lost it right there. What was that clear enough? Because I confused myself. We have all of the numbers except for 2 and 5. So to do this, we're going to iterate over the length 5s again. Fives dot iter dot find v, where v union 6. That count equals, what was it? 4? I don't remember. 7. Of course I got it wrong. 7. And this has to exist. Six. We should filter this. Dot filter. What's the other length? 5? 3? Yeah. And then this is 5, and this is, why is that not filterable? That's got to be this. And then we filter out 3. We don't need to do this. 3 and v is not equal to 2. And this is find. And this needs to be an and. And then we have everything. Why is .union syntax highlighted weird? Because union is a keyword. So that's fun. Because union is an actual thing in Rust. A union is kind of like an enum. Or, I don't know that I explained that correctly. You don't come across unions very often, is the way that I'll put it. It's a way of specifically like packing variants of an enum or a struct into a single place in memory and just unsafely reading them out as bits. It is just a struct. Okay. I had it in my head as a union, but it's just a struct. Yeah. It's not colored like that because union is a keyword, because you can do union thing instead of struct thing. And I'm sure that the syntax highlighting in VS Code does like some kind of regex and just says, if we see a union, then we do it like this. But in any case, we had an unwrap on 142 that failed. So V union 6 is the thing. The syntax highlighting is some huge regex. Yes. It's also some huge regex when we do like it on the front end and stuff. Okay. CFGED gives us EB. DCBFA gives us EB. Why is that? This is supposed to be 2 and 5 against. Six. The union of 6 and 5 should be 1, 2, 3, 4, 5, 6. But it's giving us 2 characters for 6. I messed something up. Why is 6 length 2? Yes, that is the question. Oh, for 6? Wait, for which one specifically? For sets? For 0 and 6? No. Okay, that works. Okay. Ready? I think this works. So now we have outputs, and the outputs really need to be a hash set. We get rid of this because we don't need this. Sorry, one cell. One cell is really cool. We ended up not needing it. Our parser up here is going to give us hash sets for the outputs because that's where we're going to compare against now. Puzzle input 2. This is also going to be this, which gives us signals needs to be this, and this iter needs to happen on the outputs. That didn't work. What did I do? I think it's going to be a ownership issue. Oh, this collects into a vec of hashtag cars. Whoops. I did it right there. Why didn't I do it right before? Process line. Process line is erroring out for some reason. What did I mess up? This is what I messed up. type signature for the function. Okay. So now we have an interesting thing to do. I think we can key off the hash set. Like this, 1 1. Expected hash set. Found a reference to a hash set. Fine by me. Okay, we can't actually do this. That's unfortunate. Let's see. We need to do outputs. Dot iter. Dot map. The output can be matched on, hopefully. So the question here is, do we collect this into a set of integers, or I think we collect it into a string, and then we parse the integer out. Two, three, four, five, six, seven, eight. Eight, nine. 2, 3. Yes, this looks awful. And yes, I'm still doing it. 6, 7, 8, 9. You have to do math on them, so integers. Do you have to do math on them? I mean, like, the goal here is actually to nums.parse usize unwrap. Right? Part 2 test demo data. No, we are failing currently. It's giving me a warning for these. Unreachable patterns. Right. Um, what is the guard pattern for this? Rust match guard pattern. Is it with the thing? So we get to take this, and we get to go and then we paste. Tell me these are all different. Oh my god, what have I done? Sure, we'll do that. We did panic, so let's do... AFDEGC. I guess we could log all of these out. See, we did all of these correctly, right? 3 5s, 3 6s, 1 4 7 8. We should have every combination, right? All right, let's take a look at the mess that I've made. EDAFGC. They are right, it's not there. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. What is this? Did we do the test on the test input, or is it running on actual? Okay. It is on the test input. Let's take a look at the test input. This is... They won't be in the same order. No. Yes, it is called guards. It's super useful. I have the docs pulled up over here, but if you go to, I guess Rust by example has an example, but it's mentioned in other places too. I don't see this in any of the output, actually. This looks like it's shorter letter. I know, there it is. That doesn't exist in the input. There it is. GADFEC. So 1, 2, 3, 4, 5, 6. What is this? EDAFGC, EDAFBC. One, two, three, four, five. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We're pulling in a 5 instead of a 6 somewhere. Okay. Can we... Is it useful to look at this and match them all up? BCA EDF. BCA EDF. BCA EDF right here. And I just checked one, so we have one ADGEB, ADGEB, DACEB, DACEB. This is it. 2 and 3 are the same. Why are 2 and 3 the same? Three is length 5s, intersection with 7. I'm inclined to think that 3 is right and that 2 is wrong. Bug V Bug 6. Let's finish looking at this first. So 2 and 3 are the same. CFAB. FAEDC. FAEDC. ECDFBG. ECDF. ECDFB. ECDFBG. So 6 is correct. DCB. EGA. DFCB. EGA F. DCB. Yep. EDA FGC. Is EDA FGC the one that we're looking for? Yeah. Okay, I think everything else is correct. So it's just 2. So way up here, we've got V, C, D, E, F, G, and 6. C, D, E, F, G, and then A. So the union of... Why are we testing 3 times here? We're not supposed to be comparing against 3 here, are we? How were we supposed to get 2? 6 union 2. Why am I filtering 3 out? GAEDBD. JEBD. Okay, so these are no longer the same. We still have a problem, but they're no longer the same. Okay, 3 is length 5's, intersection whatever. So this should filter out and include only the ones that are not 3. Let's put an extra debug down here so I get some space. Six, 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 six. Okay, let's do... Okay, so the one that it panics on is this one, V6. DBAGE, DB 3, 4, 5, 6. 1, 2, 3, 4, 5. Need to get some food soon. Okay, V6 and 1, 2, 3, 4, 5, 6, 7. So BDAGE should be 2. It is. So that's right. We're still panicking now at DGACFE. Is another one of these the same? Did I mess something up while I was doing my debugging? Let's do... Just eating lunch a tad bit later here? Yeah, it is a little later by you, isn't it? Also, hello. Hello. Good to see you. Unfortunate to see you under these circumstances. 8304, 781. 8304, 781. We're missing the entire first number here. 1107. So some of these numbers are just wrong, like straight up wrong. We messed something up in the process. What is the... Did they give us any other useful information? Okay, so for this one line, is this the first line in the test input? A, C, E, D, G, F, B. It is not the first line in the test input. Let's do this. Let's copy, let's paste, let's comment this out. This is going to be 5353. And I am going to grab this line, this random line that they decided to insert here. Of course that passes. Oh, come on. Really? Is it not testing it? Really? No, it's not because our sum shouldn't be that. It's because there's something actually wrong with the logic. Because we panic here, which means that we don't have a match for that. This is the outputs, right? And we're matching over the outputs and seeing like if the output matches the number that we identified as 0, then we return 0. So we are incorrectly identifying the numbers. Why are some of them shared reference to X and others are X? Because when I was doing all these finds and things like that, I messed up and I didn't keep them the same. That's why. It has nothing to do with like anything interesting. If we look at the types here, you'll see that they don't necessarily match. Because like when we find here, we have a shared references for the first 4. And then when we find here on this one, we don't. We have a double shared reference because this is the second iterator. So basically we have like sets.iter, and then we have length5s.iter. And length5s.iter is a pointer into the, or not a pointer, but like it points into the original like data. So we're kind of reference away. It's I could avoid that, but I chose not to avoid that. So, rip. Okay, what are we doing here? We're doing these, I think, and then we are doing just the line that we have here. Maybe we got lucky and the test unrecognized option, no capture. What did I do wrong? What did it do though? What did I mess up? Cargo test, no capture. That what I did. Do we not have any debugs left? Did I take them all out? Is that what the problem here? Can we find which line works and just apply our logic to it out of code? That's what I'm trying to do. I'm trying to identify which numbers are wrong here, but I need my test output. which doesn't want to debug out for some reason. There we go. We're only testing one line and it's working. Yes, we're only testing one line and it's working. I want to debug all of these out for the success and check them against the actual the verified answers over here to make sure that we're actually getting the right ones and that we're not just like getting lucky, basically. Okay, so 0 is CAGEDB. CA, that's not right. First one is not right. One is AB. So 0 is wrong, 1 is right. 2 GCD FA is right. 1 and 2 are right, 0 is wrong. FBCAD is right. EAFB is right. I am just checking them all. So C5 is CDFBE, which is right. 6 is CDFGEB. CDFGEB. 6 is right. DAB is right. 8. ACE DGFB. DGF. 8 is wrong. FB. No, 8 is right. 8 is right. 9 is Ceph ABD. Ceph ABD. So the only one that's wrong is 0. ADE BCF. ADE BCG. Why do we have G there? And there's no 0 in the output, so we don't notice. But 0 is wrong. How did we get 0 wrong? Length 6 is iter, filter, V is not equal 9. Symmetric difference with 1, count equals 4. So symmetric difference between 0 and 1 should be 1, 2, 3, 4, right? What else is in the zeros? The zeros is 6, 1, 2, 3, 4, 5, 6. So symmetric difference between 1 and 6 should be 1, 2, 3, 4, 5, 6. Between 1 and 9 is 4. That's our problem. Right there. So let's get this test running now. Yeah, and now we have a number. I'm going to run this in a second. I'm going to get some more water. And I will be right back. So what was the issue zoned out for a minute, but yeah. The issue with the actual solution, which, okay, so to be fair, we haven't submitted this yet. We don't know if it's correct, but I was filtering out wrong, basically. So let's get rid of all of these debugs. At 0, this was not equal. This was equals 9, which happens to match the symmetric difference for 1 and 0. So they're both length 4. So we were getting a value here that we shouldn't have. And then I don't think 2 was actually an issue. So what is our actual... $61,229, which is what we get. Huzzah. It's fine. I wrote it kind of ad hoc, so having a little logic bug is not unheard of. Auto run and bin part 2. That's the answer. So we were correct. The only problem was that I typoed, basically. What even is this photo right now? The thing that they're rendering. It's like a person, a reindeer, I don't know. Well, this was by far the hardest one so far. Yeah, I guess it depends on what you consider hard, right? Like, I think the key insight here, for the way that we did it, at least, I'm sure there's like some mathematical awesome way to do it. But the key insight here for us is to use hash sets. And once we have hash sets, we can just push things together or pull them apart. And intersection, I don't even think we ended up using difference. Yeah, symmetric difference, intersect, and union. And we use those 3 APIs and they just go together and come apart and we're done. So from there, it's just a matter of like identifying the patterns. So I think this was more mechanical than like hard, I guess, is the way that I would put it. I feel like I want to rewrite this, but I don't think I'm going to. I think I'm just going to leave this one for today as a one-off. I think there's things we could do around the swap remove. Like for 1, 4, 7, and 8, we could swap remove here. And then for the 5s or the 6s, we could do like a group or something. That would probably clean up the code a little bit and make our intent a little bit cleaner or clearer. Yeah. For a couple of these finds can return like 2 values or something. So we could do like a find map and then have 2 and 5 in the same. Not too fussed about it though. I think this was just kind of a messy day. So we're gonna leave it as being a messy day. We'll run the heap allocation stuff, I think, just for completeness because we have been. But I'm really not gonna do anything to change it. So it's just going to be what it is. I think the switch from algorithmic to deductive was what made today's feel so different. Yeah, I suppose so. I guess yesterday's was more of an algorithm-y kind of thing. Dat. So part one, 40K kilobytes. Part two, probably not that different. 500K. So I'll throw these in to the README just so that we have them. That's the wrong thing. Copy. Paste. We didn't do criterion today. I think we're already set up. We could if we wanted to. Opt to get rid of that. There's our number one. I think especially since we're iterating 50 bajillion times, it changes things. We could turn those into something else. Do we already have criterion in our benchmark already, actually? Benches. Let's get rid of opt2 here. And then actually we do have it. So I'm going to comment out the DAT profile so that we can do this. And then we're going to do cargo bench. $71,000 iterations, dang. So part one runs in about 70 nanoseconds. Part two runs in 2 milliseconds. So quite a bit more work. Again, I don't think I'm gonna do anything to change this today. I think I'm just gonna leave it. But it's good to have the information, right? Just because you're measuring doesn't mean you need to change things. And if we wanted to change things, we now have the information to do so. So it's nice to have them around. And it wasn't even a hard setup, right? It was already set up from yesterday. So I'm going to call it on the stream for today. Same time tomorrow. So day 9. And I will see you then. Thanks for hanging out.